All right. So this lesson will teach you how to solve radical equations. And the plan for this is I'm going to give you 3 steps that we follow. So we have done this before, okay? But now this is going to apply to any radical equation. So what we do first is we isolate the radical. So this is the symbol for radical. Okay, so you'll have 2 cases today. You might have radicals on the 2 sides of the equation, but still what you do is on step number 2, you raise both sides of equal sign, okay, to the same power. So if it's the square root, then you take the square of the 2 sides. If it's the cube root, then you take the cube root. I mean, you take the cube, not the cube root. Step number 3, once you raise the 2 sides of the equation to the same power, then that'll give you a linear equation today. So you can solve linear equations by now because that's what you have been doing for the last couple of years. So the first example is very simple because as you can see, this square root of x is by itself on this side and this 4 is by itself on that side. So then all you have to do is really to get rid of the square in this case. So let's see, we got to take the square of this side and we take the square of this side. So what you do to one side, you have to do to the other. So that's step 2. So then that gives you, or that tells us that x is equal to, when you take the square of the square root, this gives you just a 4. So this is the solution to this equation. To the second example. Let's go into the second example. Notice again, the radical is isolated. So step 1 is done. So all we have to do next is go to step 2. So this is not the square root, this is the cube root. So let's raise this side to the cube and that 4 also to the cube, or a 3rd power. So then when you raise the cube root to the 3rd power, that gives you only what's inside of the radical, which is x plus 21. And it cancels the cube root. But then you have to cube 4. So 4 cubed is the same as 4 times 4, which is 16, times 4, which is 64. Okay. Then when it's solved for x, so we subtract that 21. So you guys are good at this by now. So then x equals 64 minus 21, which is equal to 43, right? So that's the solution to this equation. Example number 3. So for example number 3, the radical is not isolated because there's a plus 4. So I'm going to subtract that 4 from both sides of the equation. So then this gives me the cube root of x minus 8 isolated on the left side. But then when I subtract, I don't know why I subtracted 2, it should be 4. So minus 4. So I'm going to go back and correct that. So minus 4 minus 4. So then 2 minus 4 is negative 2. Now to cancel the cube root, we take the cube, or the 3rd power. Okay, so raise this to the 3rd power and raise that negative 2 to the 3rd power. So then this gives me x minus 8 without the radical. But now when I cube negative 2, that's negative 2 times negative 2 times negative 2, which is equal to negative 8. Okay, then I'm solving for x, so I'm going to add 8 to both sides of the equation. So then we find that x is equal to 0. So that is the solution to the second example, the second equation, the 3rd example. Let's go to example number 4. Again, this radical is not isolated. There's a plus 3, so I'm going to subtract that 3 from both sides of the equation. So then that gives me, notice this is a 4th root. Okay, this radical is a 4th root, so this is a 4th root of x plus 7 is equal to 6 minus 3, which is 3. Again, the radical is isolated. Let's take the inverse power, which is the 4th power. So then this gives us the radicand, which is x plus 7, and that is what's inside of the radical. Now you take the 4th power of 3, which is 3 times 3. That's 9 times 3, 27 times 3, 81. Then since we're solving for x, let's subtract that 7 from both sides of the equation. So then in the end, the solution or the value of x for this problem is 74, right? So x equals 74. And that's a solution for that example. Example number 5 next. Okay, so notice example number 5 has radicals on both sides of the equation, but before I can raise the radicals to the square, because these are square roots, I need to move this radical to this side. So I am going to move that radical to that side. So notice that it's negative. When I move it to this side, it becomes positive. So then we have square root of x plus 3 is equal to the square root of 2x minus 1. Okay. From there, we want to cancel the radicals. So this is the square root, so we take the square. So the square of this side and also the square of this side. So then that gives us only the radicand of this side, which is x plus 3, and this one is 2x minus 1. Since I have 2x's on this side, I'm going to subtract this x from both sides. So minus x here and minus x on the 2x. Also, I'm going to have the numbers on this side. I have a minus 1 here. So I'm going to add 1 to both sides of the equation. So notice I'm doing 2 steps in 1 here. So then this x cancels and this minus 1 plus 1 cancels. But now we're adding it here. So this 3 becomes a 4. And that is equal to 2x minus 1x. Just x, which means x equal to 4, 4 equals to x, 4 equals x means the same thing. So that is the solution to example number 5. Example number 6, notice that there's a radical, there's 2 radicals on this side. I'm going to bring this one to the other side. But this one can trick you if you don't pay attention to it. Okay, so I'm going to move that to this side. So then we have the cube root of 2x plus 1 is equal to 2 times the cube root of x. Now, what I'm going to do next is, since I have these 2 sides, these 2 radicals on the 2 sides of the equation, I want to cancel the cube root, so I'm going to take the cube of both sides of the equation. And then for this one, I'm going to do something different because of that too, because you might not catch it if I don't do it like this. Once I present it to you, I think you'll be okay. So that cube applies to the 2. So you're raising 2 to the 3rd power, and you're also raising the cube root of x to the 3rd power. Okay, so this gets distributed to both. So then this one here just gives you 2x plus 1, and that is equal to 3 cubed is 8. And then open parentheses. I don't have to use parentheses here, because if you take the cube of the cube root, that just gives you x. Once we have no radicals, then you start solving. So I'm going to subtract the 2 x's from this side and also from 8x. So then the x's go cancel here. So then on this side we have 1, and 1 equals 8x minus 2x, which is 6x. Then I'm going to divide by 6. So then we find that the solution to this equation is x equals 1 over 6, or 1/6. And that's the solution to this equation. Okay, example number 7 next. Again, we have a 2 in front of this radical. We have radicals on both sides of the equation. Let's raise this to the cube, because this is the cube root. So then this gives me 2 cubed, which we just did, right? So that's going to become 8. But now watch this one. This is a binomial. So 8 times x plus 1 is equal to x minus 2. So this one could trick you if you don't pay attention to it. That 2 became 8, but this is a binomial. So what we do next is we distribute. So 8 times x is 8x, and 8 times 1, that's 8. So this is equal to x minus 2. What I am going to do is I'm going to have all the x's on this side and the numbers on this side. So I'm going to subtract this x from here and subtract that x from 8x. I'm also going to bring this 8 to the other side. So minus 8 here and minus 8 on this side. So then no more 8's on this side and no more x's on this side. They get canceled out. So then when you subtract 1x from 8x, you're left with 7x. And then when you combine -2 and -8, they combine to -10. Okay, then one more step, which is we divide by that 7 so we can get the value of x. So then in the end, the solution to this equation is negative 10 over 7. And we're done with example number 7. So for example number 8, which is the last example, notice again we have a 2. So we have the two radicals isolated. Let's take the cube so we can cancel the cube root. So then when you take the cube of 2, that becomes 8, open parentheses, then 10 minus 3x inside of that parentheses, and this is equal to 2 minus x. Okay, then again, just like example number 7, let's distribute. So 8 times 10, that's 80. 8 times negative 3x, that's negative 24x equals 2 minus x. And now let's have the x's on the right side. So I'm going to add 24x to both sides of the equation. And I'm going to subtract this 2 from both sides. Okay, so then the 2's cancel here. The 24x's cancel. So then we have that 80 is equal to negative x plus 24x. That's equal to 23x. Then last step is I'm going to divide by, oh, I didn't subtract the 2, right? Yeah, I hear you talking here, so yeah. So before you call me out on it, I heard you. Okay, then divide by 23. So then 78 over 23 does not simplify, so then the solution to this equation is 78 over 23 is the value of x.